Hello everyone, I am Dr. N.Senthil, Associate Professor Computer Science Engineering. Great pleasure for me to welcome you all for this session. In this session, topic to be covered is data center design and interconnection networks, data center interconnection networks under U3 cloud platform architecture. At the end of Unit 3, students will be able to explain the design principles, architecture and enabling technologies of cloud platform. At the end of this session, students will be able to understand data center interconnection networks under data center design and interconnection of networks. The critical core design of a data center is the interconnection network among all the servers in the data center cluster. This network design must meet 5 basic requirements: low latency, high bandwidth, low cost, message passing interface communication support, and fault tolerance. Specific design considerations are application traffic support, fault tolerance and graceful degradation, and switch-centric data center design. Under application traffic support consideration, the network topology should support all MPA communication patterns. Both point-to-point and collective MPA communications must be supported. The network should have high bisection bandwidth to meet his requirement. For example, one-to-many communications are used for supporting distributed file access. Under fault tolerance and graceful degradation consideration, the interconnection network should provide some mechanisms to tolerate link or switch failures. In addition, multiple paths should be established between any two server nodes in a data center. Fault tolerance of servers is achieved by replicating data and computing among redundant servers. Similar redundancy technology should be applied to network structure. Both software and hardware network redundancy are applied to cope with potential failures. On the software side, the software layer should aware of network failures. Packet forwarding should avoid using broken links. The network support software drivers should handle this transparently without affecting cloud operations. Under switch-centric data center design consideration, there are two approaches to building data center scale networks. One is switch-centric and the other one is server-centric. In a switch-centric network, the switches are used to connect the server nodes. The switch-centric design does not affect the server side. No modification to the servers are needed. The server-centric design does modify the operating system running on the servers. Special drivers are designed for relaying the traffic. Switches will have to be organized to achieve the connections. This diagram shows a fat tree switch network design for data center construction. The fat tree topology is applied to interconnect the server nodes. The topology is organized into two layers. Server nodes are in the bottom layer, and edge switches are used to connect the nodes in the bottom layer. Upper layer aggregates the lower layer edge switches. A group of aggregation switches, edge switches, and their leaf nodes form a pod. Core switches provide paths among different boards. The fat tree structure provides multiple paths between any two server nodes. This provides fault-tolerant capability with an alternate path in the case of some isolated link failures. The failure of an aggregation switch and core switch will not affect the connectivity of the whole network. The failure of any edge switch can only affect a small number of end server nodes. The extra switches in the pod provide higher bandwidth to support cloud applications in massive data movement. The building blocks used are low-cost Ethernet switches. This reduces the cost quite a bit. The routing table provides extra routing path in the case of failure. The routing algorithms are built inside the switches. The end server nodes in the data center are not affected during the switch failure as long as alternate routing path does not fail at the same time. In the summary of the session, we learned about data center interconnection networks. I hope you found this lecture is more useful. Thank you and have a pleasant day.